So it's really an honor to have today with us Professor Ian Akyildiz. Professor Akyildiz received the PhD degrees in electrical and computer engineering from the University of Erlangen, Nuremberg in Germany in '84, and is an advisory board member at the Technology Innovation Institute Abu Dhabi in the Autonomous and Robotics Research Center since June 2020. He is also founder and president of Truva, a consulting company based in Georgia, in USA, since 1989. He is the founder and the editor-in-chief of the newly established International Telecommunication Union Journal on Future and Evolving Technologies since August 2020. He served as the Ken Byers Chain Professor in Telecommunications, the past chair of the Telecom Group, and the director of the Broadband Wireless Networking Laboratory at the Georgia Institute of Technology from 1985 to 2020. He had many international affiliations during his career and established research in Spain, South Africa, Finland, Saudi Arabia, Germany, Russia, India, and Cyprus. Dr. Akyildiz is an IEEE Fellow since 1996 and ACM Fellow since 1997. He received numerous awards from IEEE, ACM, and other professional organizations, including the Hubble Award from Germany and the TÜBİTAK Award from Turkey. In June 2022, according to Google Scholar, his H index is 133, and the total number of citations is more than 134,000. His current research institutes include research interests include networking 2030, metaverse, hologram, extended reality communications, 6G, 7G, wireless systems, terahertz communications, and underwater communication. Today, Professor Akyildiz will talk about metaverse, challenges for extended reality and hologram type communication in the next decade. So thank you again, Professor, to give this talk, and I leave you the stage. For the attendees, I remind you that we have a Q&A panel, so essentially you can write there your questions, and we will have a question and answer session at the end of the seminar. Thank you so much, and I leave you the stage.
Thank you, Julia. Good morning, good afternoon, good evening, wherever you are in the world. Again, I told to Julia like 10 minutes ago, please do not read my biography, but she didn't listen to me. Sorry about a long biography. So today I will talk to you about metaverse. This is a hot topic, and since almost 1.5 years, I'm interested in this topic, and I would like to share what I learned and what needs to be done the next 10, 15 years. And so I call this talk challenges for extended reality and holographic type communication, which are underneath of the metaverse. And so what is metaverse? I'm sure you see that in the commercials, at least in the United States. You heard the Facebook name changed to Meta now. So it's really up and coming. If you still did not hear, maybe it's time to wake up and pay attention to this direction. Metaverse stands for meta is Greek beyond, and verse is universe. This terminology is originated from the science fiction novel called Snow Crash by Neil Stephenson almost 30 years ago. And now we cannot say yet another science fiction, it's not. So metaverse is a simple definition, is a network of connecting physical and virtual worlds seamlessly. So there will be no separation between digital and physical world. And how can we achieve that? We can achieve this due to the convergence of key emerging technologies, such as you see here, holographic type communications, virtual reality, mixed reality, augmented reality, and also all these new gadgets and devices like iPhones and cell phones, as well as laptops and desktops, etc. So what you see here is you're mixing the virtual world through these technologies. And we are here, and at the end, we are in a world of so-called metaverse. So it's like mixing the physical and virtual world. So this is a fantastic area, you can imagine. And so the metaverse, I'm sure you will get this question a lot. It's a huge area. So I have these three pillars presentation here. One pillar is called M worlds or meta worlds, metaverse worlds. And they're really kind of like software platforms, and they will help us. I have like some examples here, but by no means this is a complete case. Like it will help us to increase the work productivity, interactive gaming, learning, e-commerce, real estate, remote healthcare, fashion, shopping, tourism, real estate. As I told you, that there are many hundreds of examples. Believe it or not, there are more than 10,000 metaverse worlds already existing. I have some companies here on the right-hand side. In fact, I prepared a lot of details about these companies, but then I thought I would remove them. It's really interesting. They started the last 5-6 years ago, or the last 2-3 years ago. And in some cases, you can make $1 million per day. I'm not kidding. So these are kind of like these platforms, software environments. They create this kind of like metaverse world, right? And you can go and play around, not just gaming, right? You can do like real estate business. You can do fashion business, shops. So it's really a fantastic world. And then another pillar is, we started with web like almost 4 years ago with 1989. We had this web version 1, 2. Now we are in the web version 3.0, which is also underneath of the metaverse. So it's completely decentralized compared to Web 2, which we are using currently, and autonomous. It's heavily based on AI and machine learning technologies. And also the key secret sauce is blockchain based, and they enable cryptocurrencies, because you need all of these for these platforms that I just described to you in the metaverse worlds. And intelligent adaptive applications, and also semantic technologies like the qualitative communication, not quantitative like we used to do. And then I have here another pillar is extended reality, which is the umbrella terminology for augmented, virtual, and mixed reality, and then holographic type communication. So this talk will be based on this pillar here. And it will be interesting to have a tutorial or a lecture or class teach all of these here. Maybe in the next time I can do that. So the market is unbelievable. Like you see here, current market is like $130 billion. And in 4 or 5 years, the expected revenue is like almost $400 billion. Is unbelievable. And the majority of this revenues are based on the so-called virtual asset economy, like all the hardware, software, and mobile advertisements for extended reality and holographic time communications, and also existing technologies like PCs, desktops, cell phones, etc. Then we need gigantic bandwidth. You will see that. I will explain to you. And then they are using also existing blockchain networks and cloud infrastructures. So the bottom line here is that some of these technologies are existing, some of them are still under progress, like Web 3.0, as well as many of these issues that I will point out in this lecture. So I mentioned to you about web generations. So in 1989, Sir Tim Berners-Lee introduced the World Wide Web. I remember like yesterday. It was very primitive. Everything was fixed, and all centralized. And in 2004, Tim O'Reilly started to use more sophisticated software, and like we could do dynamic animations, etc., as you know, and also more and more sophisticated use cases and websites, and still centralized. And then in Web 3.0, the idea came from the Ethereum, which is a Bitcoin company, founder Gavin Wood in 2015. So it's still under development. You can see there's a formatting issue here. So we're moving from all these classical software and resources like Dropbox, Google Drive, Facebook, Twitter, to new resources like the Brave. So I tried Brave. Sometimes it works, sometimes because the websites are not that sophisticated. So that's why I say here, Web 3.0 is still under development, and some of these other resources are existing. And as I explained to you, they're realizing these metaverse worlds, qualitative communication, like semantic, and heavily based on AI, ML. And the keyword is also they are centralized. Every user owns a piece of this web, and then heavily will be using edge computing because of the latency problems I will mention to you. And as I told you, it's based on digital ownership. That's why we have the distributed version, like cryptocurrencies and also like so-called non-fungible tokens. It's a really interesting concepts here. I wish I could explain them all to you. So this is the slide that I got the motivation from the ITU report, but that's not, you know, this slide is not from this document, by the way. So they call it Networking 2030 Group. So I expanded it to 2040, and then also I changed some of this like services. For example, I focus on metaverse, like underneath XR and holographic time communication. And then applications are, again, by no means this is complete, but they give you some ideas about conferences, tourism, remote assistance, healthcare, education, automotive, entertainment, and industrial automations. I mean, name them. So there are like thousands of applications, as you know. And the technologies, you will see the current 5G and like the next generation, like 6G, still will have problems to realize these services. That's why I have these horizon more like 10 years down the road, maybe 7G. And there's this new IP issue, like new internet. So revisiting the internet again. Then for the latency problems, because these application services need very strict latency. So there's so-called high precision networks. That's the terminology that people are using. Another is federated networks and edge intelligence. And again, this pops up all the time, like qualitative, like semantic communication. Of course, all of these technologies are beefed up by security, privacy, and trust solutions, algorithms. And of course, AI and machine learning will support these new security, privacy, and trust solutions. So we cannot use these existing ones and then say, you know, we can solve all this, you know, technology, security, privacy, trust problems. So in other words, we really have a new era of communications. Unfortunately, many researchers in the world, that's my experience in the last 40 years, they are focusing on something and then they dwell on it the next 10 years. So all these interesting topics are there, and you know, and they wake up after 5 years and it's maybe too late, right? So here is, again, my interest is more from the communications perspective. And so the last 2 years, as I explained to you, I work with one of my grandchildren. He's my grandchild. So we wrote these extended reality paper as well as hologram type communication. So they're available publicly. It's in open access. So you can read all the things that you need. So I will explain you what are these technologies, right? So extended reality, as I told you, it's an umbrella term for augmented, mixed, and virtual reality. And reality is like we have this, our physical world, human perception of real objects. We have 5 basic senses like sight, hearing, touch, smell, and taste. And then when we go to here, you can see the reality here is on this side, real environment. By the way, this taxonomy was introduced almost 30 years ago, 1994, by Milgram and Kishino. So it's not new, but it's really fantastic, as you see, but expanded in the recent years. So real environment is here. And the other extreme is so-called virtual reality, virtual environment, which is creating, totally virtual environment, digital virtual objects to represent the same real senses and environments. In between, we have this augmented reality, which is real environments, but augmented with some virtual objects, information. So like little bit pieces of the virtual objects. And augmented virtuality is more virtual objects, more percentage, as I show you here. That is, if we have low percentage of virtual contents, we are in the augmented reality. We have high percentage of virtual contents. We are moving more and more virtual reality. So these are the two in-between solutions, and they are also known under the mixed reality. And then all of them is under the extended reality. In order to realize these objectives, we really need new technologies. You will see that also. Even the 5G, 6G may not help that much. And then AI, machine learning, and Internet of Things, next generation IoTs can help us, right? So there are already existing devices. They're like $500. You can buy them in Amazon. Reality, like you can have naked eye or optical glasses. You see here an example, with your own eyes, you see a real view of a trail. And then augmented reality and mixed reality, you have these so-called translucent displays. So you have a glass, for example, with some cameras and some little computers here. And this is like totally a gadget here. And then you can see in the augmented case, we have some virtual objects that the physical environment is enriched by these augmented objects or virtual objects, like directions, and also the trail, for example, and the times, etc. Right? And then when you have interaction with, like, you have a menu and you can enter what you need and all that, kind of like interactive. So we are moving more and more called like mixed reality. And then if you have totally in a virtual world like this, occlusion display, so you can play games and also interactively do a lot of things. So this is the big picture of these different technologies. So believe it or not, I call it then and now. So this Sensorama was introduced to virtual reality in 1962. You can see the person here. And then in 1968, augmented reality, sword of Damocles. That's the famous Damocles sword, right? So that's here, right? So it's really very primitive after so many 5+ decades. So now we have these, like as you have seen, headsets, and like here, but again, they're also tethered, like connected, wired cable to some laptop or some equipment. So so there are many use cases I mentioned to you. I have by no means is again a complete list, like remote surgery or surgery with all these enriched virtual environments, like a soccer field or baseball field, like workshops, automotive, tourism, completely virtual cinema at your home, like gaming, real estate. I mean, I have a list of cases here. Like you can also play around how a piece of furniture looks in your living room. So again, by no means these are the complete examples. You can think thousands of other examples, right? So then there are existing devices, as I told you, like from all these companies, like Oculus, Microsoft, Epson, Huawei, HTC, etc. And I put this table here. I cannot go through all of these specifications and their features, but all I want to say is they're already existing and they're not that costly. Even in Amazon, you can buy some very primitive cage, like carton type, and then you can put your cell phone in and you create your own gadget. So these are like a couple $100, as I told you. So as I explained to you that XR devices are mostly tethered and heavy headsets, low quality content, and inconvenient mobility support, and then you can have really sickness. Like I'm very, very sensitive, really. So you can get sick for prolonged use. So what are the future, like untethered wireless headsets? Even maybe much more, how can we get rid of the headsets? I don't know. Lightweight headsets, high quality contents, and also mobility support. These are the question marks, right? So now there are these communication architectures, as I told you, because you may say, where is the communication comes into picture, right? So now we have seen these devices here for virtual and augmented and mixed reality. And then they are like either wired, I call this word tethered, or wireless. They are connected to some backbone, like a laptop or iPhone or desktop, iPad. They have some computing and rendering. It can be ad server, and even they can use core cloud, some software, right? These are the servers. So, and then they can do sensing, transmit, process, send it back, and then, they can do video recording, and you can do, when you receive this information back, you can do decoding and displaying. So there is a communication between some devices in the background, and that can be mostly wired for the time being, future more wireless and mobile, right? So that's what we're talking about. Similar in the virtual reality. As you see in the virtual reality, we don't do video recording here because we are not like mixing it with the physical reality. So there is no video recording, but everything else is almost the same as in the augmented and mixed reality cases. And so one of the, I will come back to these research challenges, right? So the latency is a big problem. People who are playing games, I'm sure they understand my point. They really need extremely tight end-to-end latency so they can react to it, right? So now, like also the data rates are really a big headache. For the time being, nowhere we can reach these terabit per second data rates and like 1 millisecond end-to-end latencies, right? So we are far away from that with these current technology. I have it, it's called here stage 1, or you can also call it generation 1. And then in generation 2, we'll go higher data rates and also shorter end-to-end latencies. And of course, in the generation 3, hopefully, that's why I have it like 10, 15 years down the road, 1 millisecond and several terabytes per second, right? So now, after some introduction to extended reality, I will go to holographic time communication. So what is a hologram? So a hologram is photographic recording of a light field, right? Like here you can see. So you can see from different angles, like these apples and oranges, and you display it as a hologram, right? And it consists of a set of virtual 3D images, like here, right? They reflect real physical objects. They preserve the depth, parallax, and other properties of the original items, like the apples and oranges, or person or object. You will see that. So holography is a photographic technique that records that the light scattered from an object and then presents it in a way that appears in a 3D format, right? So like here in HCC, we want to realize all these 5 senses on the long run, right? Sight, hearing, touch, smell, and taste. Good luck, right? So in extended reality, we have all, sight, hearing, and touch cases. So the challenges are huge in the holographic type communication from these 5 senses perspective. And then there are, again, many use cases you have seen before, but now more like in a real life, right? So they're like, the soccer field will be like as if you are next to the soccer field and the players are next to you, or the boxing game, right? So it's like they're here next to you or in front of you, or you can have a panel here, so some physical ones and some through the hologram, as if they are there. In fact, this is really a hot topic, although it started many years ago. You can see in the past, holograms, but they really look like a skeleton, right? It's a very, very primitive, this holograms, a person is coming on the stage, but now it's more sophisticated. Like 1 month ago, I was in Las Vegas. There's a real concert by Whitney Houston. Honestly, it's like always sold out. So Whitney Houston is like as if she's there and singing. And then there are also some other shows, like they show Marilyn Monroe and Elvis Presley. And then some of you may have heard in May 30th this year, ABBA gave a concert in London, all holograms, right? So really the technology is getting better and better so that we can have each other like next to each other, right? But here you can see still it's not what we want. So it should look like right they're there, right? So that's the future, okay? So for the architecture, this is the abstract picture that I want to share with you. So now you have these source, wide field, like normally thousands of cameras, or hundreds of them, sensors, RGBD cameras. They take pictures from different angles. Like we call this multi-view 3D point cloud capture, right? So now all this is in the cloud, 3D point cloud compressions, and then streaming data like TCP/UDP's protocols are supporting this transmitting computer or edge server. They can be at the same place, or we can go to an edge server next to the internet and then transmit. And internet can be wired or wireless support, right? And then at the receiving end, we can have an edge server or a receiving computer, depending again, separation or at the same location. So we do 3D point cloud decompression, and then of course have these transport layer actions, and then we display them here on at the destination, right? And so the rendering process is called preparing the display of the virtual contents, as if that these objects that they're taking thousands of pictures will be displayed here in a kind of like physical real life shape. So let's talk about again briefly about this source networking and destination cases. So like all these field cameras, as you see here, they have multi-view images, right? They can create holograms in two types: image-based holograms or volumetric-based holograms, which is the current trend, okay? Which is an array of images and depth information are used to create point cloud. And then the actual object is adaptively rendered for any view angle. So then you can do, as I explained to you, point cloud compression in order to save some bandwidth, or you can immediately transmit them, but then the bandwidth requirement will be gigantic, more than terabit per second data rates are needed. So there is a trade-off, right? So if we do compression, we will save some bandwidth, but then we will have more latency because we'll do compression and the destination will do decompression. But if we transmit right away without compression, then we'll need a higher bandwidth. So it's kind of a trade-off that we have to somehow optimize, right? And the data rates are gigantic, as you see here, as a human size here. And you can see these tiles, like little things, right? A tile is 4 by 4 inches. And just to send one tile, we need 30 gigabits per second. And human, it's like 72 multiplied with 20 inches. then you need 4320 gigabit per second, like 4 or 5 terabit per second. It's unbelievable data rates are needed, as you can imagine. So when we go to the networking, as I explained to you, the source, all these cameras are collecting these different views, and then we can do compression or no compression, depending again. We can have a computer at this site or and an ad server, or both of them are at the same location, and we transmit. We need new internet support. You will see that. And then, of course, in the destination, we do the reverse process and display the holograms. And then, like hologram display for the naked eyes, you can see light field display, like more than 1,000 views, or volumetric display, as you see here, more than 20 views. And extended reality compared to holograms, we have like head-mounted displays, like more than 2 views compared to 1,000 views here, right? And then currently we have 2D displays, cannot display holograms, just 1 view. Okay. Then the metaverse requirements, like again, I go back, MR and AR as well as hologram, right? So you can see data rates are 35 megabit per second to 15 gigabit per second. We can achieve these numbers somehow with the current technology, but for hologram, we go to 1 to 10 terabit per second. So we are far away from that for the time being. Again, of course, there are people say, oh, we support 1 terabit per second. Like I have Wi-Fi here, but when you start to measure, the reality is different. Anyhow, so latency, we are still struggling with end-to-end latencies, like 10 millisecond. We are talking about less than 1 millisecond. And then synchronization will be a big problem. And also like these gadgets, as I told you, we need new technologies for these headsets and supporting devices. So let's look at the big picture about metaverse research directions from communications, networking, and computing perspectives. So again, these are just my suggestions. That doesn't mean they're all complete. So in communications and networking, we have the challenges: high data rates, terabit per second, and extremely low latency communication requirements. Can we do it 6G and beyond? We'll see. Qualitative communication like semantic, high precision, end-to-end latency issues, federated networks, and AI, machine learning empowered networks. And then we need, of course, I did not mention about these hardware and software developments like metaverse servers and user devices, right? We need new devices, how they can predict the user motions, how can we do a 360-degree video capture, synchronization displays, multimedia, all these 5 senses, right? How we transmit and receive them. And then edge computing, right? So again, edge computing will help us, especially for the like end-to-end latency issues, but also offloading some of the processing to the edge servers, for example. You can do like compressions and decompressions, and also we can have real-time processing in those edge servers. So let's go through some of these research issues, and I want to point out what we are trying to do. And of course, there's no way that we can solve all of that, right? So we have 2 projects, the XRE, and then enabling ubiquitous wireless XR with extremely high quality expectations. And then the other one is Holo for All project. I have this, my Chinese gang, my former students, they're professors now. And so we had a tutorial on IEEE ICC conference on hologram, and we talked about Holo for All case. So it's really neat ideas. There are neat ideas there. So let me show you Holo for All architecture. We want to deal only with single camera. It's really interesting. Instead of thousands of these cameras, we'll have just single camera. And this Chen guy from University of Florida is a guru on that. So he has some very good ideas and patterns. And then we have these compression techniques and also some new ideas. Ray Dye or April Dye is doing all of that. And then we have all these protocols, AI and machine learning. Wang Pu is doing that. And then, of course, all these reverse processing for the display. So that's the holo for all. That's why we call it anybody can afford that, right? For all. And then another thing here is that, we have some primitive test bed. It's not ready yet, but, we can share it in a couple more months. So what are the research objectives? As you have seen, these two are converging to the same destination of metaverse, right? The extended reality as well as the holograms. So first of all, how do we deal with high data rates, right? Then how do we take care of the end-to-end latency? And how do we take care of the semantic aspects of the communications? This is a hot topic that everybody is writing thousands of papers now, right? And then some of them don't know even why they do it. I'm sorry, but just open your eye and go to the metaverse and get some application. Federated networks, right? And then further challenges like power consumption, weight reduction, mobility support, collaboration issues. So unfortunately, we have only 1 hour and I cannot cover all of this in detail. So whatever I can cover and I will explain you. And if you really need more, you can contact me and I can share you what we have. Okay, so let's talk about how do we deal with data rates, right? So today's internet performance, when we look at the throughput, they call it Surf-Kahn and Mattis equation, that T is bounded, throughput is bounded by minimum of the bandwidth, window size over round trip time, or maximum segment size, because we are segmenting, right, on the transport layer, over round trip time, multiply with 1 over the packet loss. So when we display this, the throughput in a three-dimensional, so we have here packet losses, and here are the round trip times. So the throughputs are here 369 gigabit per second for 10 to the minus 7, and then also like the 1 millisecond, right? So like when we display, or like if you go like this. So in other words, this is showing that if we are assuming infinite bandwidth, right, from this here, and infinite window size, then it requires, that's why I'm deciphering this now here, 10 to the minus 8 here, right? Packet loss, that means ultra high reliability, and 1 millisecond round trip time, ultra low latency, in order to achieve 100 gigabit per second. It's not showing you somewhere here, right? So that's this deciphering of this. So I gave you some numbers here, but this example explains you just to achieve 100 gigabit per second, we need these. It's surrealistic now for the time being, right? So we cannot achieve these results. So how can we deal with data rates, high data rates, right? So now, with my Russian group, we wrote this kind of like overview, 8.11be, the future of Wi-Fi 7. It was published in IEEE Access. Can that help us, like going to terabit per second, like these Wi-Fi 7s? Or can we go 7G, right? Or in that paper 7G or 6G and beyond, we heavily advocate terahertz band communication, which I spent almost 15 years of my career, and we just published this an old problem revisited paper, like a monster paper explaining what has been solved, what still needs to be done the next decade. So now, as I explained to you, the 5G has limitations, 20 gigabit per second peak data rates. And now when you do measurements, like we are really around 0.1 to 2.0 gigabit per second, and support existing XR, but not sufficient for future XR and hologram. Can we do with these Wi-Fi 7s? Or can we go like, next futuristic things, like using the terahertz, right? Like millimeter wave bands. I will not recommend this really. So anyhow, reasons are, we can discuss that. So I never believe that. So I believe terahertz band since 15 years. Terahertz band will help us, but there are still many research problems there. And optimal resource allocation, like joint optimization, and then co-design of sensing communication intelligence results are needed. As I explained to you, we mentioned this research issues in this paper. That will be another topic to present for 1 hour at least. And then there is this reconfigurable intelligence surfaces, which is again, like thousands of papers have been written the last 4 or 5 years. And many of them still don't know why they need it. So they may help us also to boost up the, the data rates, for example, and also support the end-to-end latencies. So now let's look at the precise latency control. And so for that, there is this new IP notion is circling around in the ITU, especially Huawei is advocating that. So there's a new protocol stack, like I tailored that to our HR and HTC cases, and they will be sitting on top of the new IP concept. A new IP is a new network protocol to design network architecture, framework, and infrastructure with high precision latency control, new transport layer solutions, semantic quality communications, and free choice addressing, not only IP version 4 or 6. And of course, supporting also multi-sensing, etc. So the end-to-end latency control, there are some new definitions for the end-to-end latency. In-time guarantee here, again, quickly I explained to you, packets delivered on or before a deadline. And another distinction is on-time guarantee, like packets delivered between a bounded time interval between T1 and T2. And the third option is coordinated guarantees, like say these different flows, they're coordinating and they're reaching destination by these bounded times. That's like in this case, they are successful. In this case, they're not successful because flow 1 did not reach the destination. So how do we achieve these different types of end-to-end latency, right? So it's a good, interesting question. Then I'm just pointing out these issues. So there are a lot of these network streaming protocols, right? And over the top OTT multimedia streaming, like best solution transmit 2D, 3D, VR, XR, holograms over the internet for the time being. And there are existing TCP-based solutions. The most popular one is the dynamic adaptive streaming over HTTP dash, and some other ones, or UDP-based design in order to go with lower latency or reliability, because we do not have these retransmissions in the UDP case. And but then we need address for loss recoveries. And there is the web real-time communication and quick UDP internet connection. So these are existing, but unfortunately, they cannot cope with these, metaverse, like these big picture cases. That's what I'm calling for new, and also other people are calling for new research, right? New transport solutions, especially for loss resilient solutions, such as error resilient encoding, error control, error recovery, and error concealment strategies. And also better retransmission. So when we do retransmission, the latency goes up, right? So now what can we do to avoid that? Because each time you do retransmission for the reliability, we lose time. So can we avoid retransmissions? And like, for example, can we find out what are causing the packet losses and errors? Because we know that from the classical networking, right? When congestions occur, we start to drop packets. When there are errors, then we need to do some kind of error correction or retransmissions or error avoidance, for example, right? And then there are some potential solutions, like drop part of the packets. Like again, semantic communication comes into picture here. And there is also a new concept called packet wash. Or at the user end, we can do error detection and correction using, or machine learning supported new error detection and correction schemes, right? They will be much more intelligent and powerful. So these are question marks that needs to be done. And then the packet wash is the basic idea is as follows here. So you need drop some of the packets, right? That's the concept of packet wash. That is, they will not affect the quality of experience at the user end. So you can, so like, again, it will not affect the semantic meaning. And then that's why we call this semantic or quality communication, right? And then you just drop some of those, and that's called packet wash. And because the dropping packets with small importance values will not affect the semantic meaning, right? So then importance value of survivors packets can be increased by these ideas about like importance value, like some priorities, like, you put that in the header information, like precision for the latency, bandwidth and delivery times, etc. So there's a neat idea also, by the way. I call, looking into this more closely. There is another idea about, as I told you, how can we avoid also congestions and transmission error, right? So there is Jean-Pierre Wasseuse, an old-timer in the internet, IETF from Cisco. He wrote a paper about a report towards a predictive internet, like using AI-empowered network prediction, adaptive control. Again, can we do some ahead of the time, what will be the behavior of the network? This is an old problem. Again, in 40 years, we always try to predict the network behavior, right? And partly we were successful, but now with all this AI and machine learning solutions, we should be able to predict the network behavior, accordingly take some actions in the source, right? And then we will avoid the errors and congestions and also retransmission, right? So another issue here is called edge intelligence, as I told you, that can also help us for the latency reduction, like, mostly using like these oldest users, right? So when we do end-to-end latency, user to user, that can really increase the end-to-end latencies, all this processing. Can we do some of the processing at the edges? So for that, there are all these research topics. Again, this paper points out some of them, like for the content generation, they talk about edge devices and like camera sensors and some data aggregation, like fusing the collected data, but in an intelligent way, right? Because again, we have all these machine learning techniques. Data aggregation is, again, in the research world since over 20 years with Internet of Things, sensors, but now they're saying, can we do a much more intelligent way these data aggregations, right, in an optimum way? And then the user devices, again, edge devices in terms of displays, sensors and actuators. We need intelligent error correction, error concealment, user behavior prediction, quality of experience improvements, and then user motion predictions for these cases, like 6 degrees of freedom, right? Especially for the holograms, that edge servers should perform short-term predictions. Only content in the predicted field of view will be transmitted, for example. There are challenges, as we also mentioned in the paper. 6 degrees of free movement prediction is challenging, and prediction error need to be addressed here. For the networking part, the edge servers will support the networking activities. And again, can we use intelligence for computation offloading, caching, inference, and training? And can we use optimal policies to determine computational location, and et cetera, et cetera. And Like here, training efficient AI models based on limited aggregated data, inference of network status and user behavior. So there are many, many challenges you can imagine when we also look from the edge perspective. So now, again, I wish I could talk about the semantic and federated cases too, but I removed all the slides. I have them. If you're interested, I can share them with you. So I want to use further challenges, power consumption and weight reduction. As I told you that some of these head-mounted display devices need high powers. Not only the power goes off, right, the power consumption, but also it creates heat. And suddenly, you have this head-mount device, and it's like almost hot, right? And then the weight is high for these head-mount displays because they have all these CPU, GPU, batteries, storages, etc., camera sensors, and some of them are really not practical. Can you do like more practical and lightweight head-mounted displays? For example, ideas: can you offload some of the computational tasks to the servers, which we should? I mean, I showed you we have that, but more offloading. But instead of wired, can we do wireless also, right? And then wireless power transfer. We don't need to have these heavy battery. I mean, battery problems. We can do some wireless power transfer, which is also a hot research topic since many years for the terrestrial other applications and devices, as we know. Then the next question is about how to deal with mobility, right? So as you see here, that we can have the fixed users, right? But also we can have like mobile users, right? Like here, walking around. So now how do we support this? One idea is we can use maybe reconfigurable intelligence services to, follow these users. And then the problem is, especially for the mobile users, we may need handoffs. Think about like, buses or cars or trains. And then this is a question, handovers is always a problem, especially when we want to support handovers. How do we do that, right? And how do we predict the trajectories, right? Again, I want to conclude it because I gave you many directions here. So metaverse is not only an emerging technology, but also a platform for economy, entertainment, and thousands of applications. And as I told you, the pillars of the metaverse, Web 3.0, meta worlds, right? M worlds, remember, metaverse worlds, extended reality, hologram type communication are enabled for metaverse. And again, we can choose if you want to do more, software, Web3, all these nice, interesting new technologies, or if you want to do M worlds, right, the metaverse worlds, to make zillions of dollars, money. So that's, again, it's open for you. You can sell your own company, right? Or, extended reality, hologram type. Again, there are many compartments here for these cases, like, from the multimedia processing, right? Now it's called multimedia because we have 5 senses in this case, not just video and audio, right? And then you have these compression, decompression techniques, signal processing, device developments, communication issues, maybe new physical layer solutions. I told you we need like new IP, and then according protocols, maybe the old protocols are too cumbersome. We need much more sophisticated protocols. I'm just scared the computer science people write 100,000 more papers and protocols, right? So, but doesn't matter. So just write. So there are all this, of course, all this building block like security, privacy, and etc. Right. So as I told you, for the time being, again, I'm interested from the communications perspective. There is a lot of research to be done, but also by no means the other parts are also open, by the way, for the metaverse. And so we will have a lot of these new technologies that we can use to realize this metaverse. Please take my word, because I had these attacks always in my life. When I talked about terrorists like 10, 12 years ago, I say science fiction, isn't that? So metaverse is not science fiction. So I'm sure it will come more and more into our lives. Wake up and jump on the bandwagon. Do not do old stuff again and again. You can do some old stuff, but with objective of these metaverse cases. So I thank you for listening to me, and I can take some questions.
Thank you so much, Professor. Really very informative. It was a very nice presentation. I see some questions from the audience. So essentially, which kind of limitations you see in millimeter waves, and which are the benefits you see in terahertz communications?
Yeah, but that's totally off the topic. But where do you see the here Q&A? So first of all, millimeter wave bands, I never believed in them, because when you look at the my proof for that is it never took off, right? It's like not $billion industry. They say 5G uses millimeter wave bands and 60 gigahertz. Yeah, but it's not, they are not making billions of dollars, number one. Number two, the efficient bandwidth of the millimeter waves and 60 gigahertz is like 7 gigahertz. You do all of that research and all these things, the baby is little what came out of it, So that's why from day one, I said, why do we talk about 30 to 60 gigahertz? Let's go up to terahertz. That's why people say, oh, it's too long way to go. And I remember even when I talked to the Intel people, he should be ashamed of it, this guy. It's too far out. Intel, we're talking Intel. This was 2012. Anyhow, so terahertz has a lot of advantages, right? So like the bandwidth is huge, and then also technology is now advanced with all these devices, transmitters, and so the sky is the limit in terahertz. And distance was a problem. I worked like almost 10 years to combat the distance problem. Now with all this new, like these reconfiguring intelligence surfaces, that's what we had with our research with Cyprus and fourth Crete, the Wiser Surf Future Emerging Technologies Project. 5 years we long on that, 2015 to 2021. 5-6 years. So we looked at the reconfiguring intelligence surfaces to support the terahertz, by the way. That was our objective. That's why it started, So the technologies are there, and I'm expecting more and more terahertz will come out the next 5 years. But it's nothing new. I mean, it supports metaverse, right? So maybe the question is right, legitimate. What else is there? While you believe in terahertz, what? Oh, I answered it. Yeah. Is there any other question? Oh, Yusuf Nasser. I think I know Yusuf, right? Yeah. He's in. I hope I'm right. He's in Khalifa, right? Okay. So.
Yeah, definitely. I see there is a certain challenge, right, of implementing metaverse, including the mobility, as you said, right? One of the last slides. So how do you think essentially can be integrated metaverse, including mobility?
I was reading a new question, but can you repeat the question? Also, the quality is not that good, So can you repeat your question before I go to the next one?
Yeah. So essentially, how do you think that the metaverse can be included, considering also mobility, right? Of course.
Yeah, that's the important thing, right? Yeah.
Exactly.
I mean, Nowadays, mobility is very important. Like I just remembered for tourism, right? As an example, I gave you one example there. Or real estate, you're driving around, you see homes, and you can immediately check what's going on, information. So mobility is very important. But then we have new challenges in mobility. As I told you, handover is always a problem since 40 years for the 2G systems, 3G. I also spent a lot of time in my life in the 35 years ago about handovers and paging and registration. But now it's different now because we have all these contents, right? And mass media. It's not just data or voice. Even for the multimedia in the 5G, we are supporting handovers, but the challenges will be much more because we have these holograms or whatever, the extended reality things. So and then the end-to-end latency limitations, and then the data rates. So that's really a very, very challenging part. The reason is when you move, then you have to maintain the data rates, and also available resources should be there. And with all these demands, good luck, right? Even really, I was joking with my friends. So still, we are in the 5G, right? Since 35 years, I used to drive to Georgia Tech, and there's this 400. So when we came to 400, 285 intersection, always I was dropped. I'm not kidding. 2G, I was dropped. 3G dropped, 4G. And I had friends, they said, shame on you. You're working in wireless communication. You cannot solve this problem. I have no idea what the hell is there that it was always dropping, right? So 5G, right? Smooth. And so these things are still happening. So, which is good for us, we write papers and try to make money, right? Because if we solve everything, then what can we do? We will not have income. So, which is good that we have all these problems. So here's a question, shall I read it? Sami is my colleague at the University of Iceland. You forgot to mention Iceland, by the way, I'm heavily involved with them. I love Iceland, by the way, it's another issue. He says, is terahertz very close to optical? You mean in optical frequencies or like data rates? Yes. There's this free space optical systems, as that they can go very high data rates, but they have other problems, a scattering problem, and also like the alignment problems, and also very expensive technologies, right? And so that's why we were pushing in my group with my students, like Joseph gave a webinar last week, and then Chong Han and others, that and also Wolfgang Gastacker, and we were pushing for the electromagnetic communication on for the terahertz because of the advance of electromagnetic. But then there were all these challenges that we try to address. That's why. So we are pushing for the electromagnetic communication, right? Nadine Akari says, will metaverse be against green? No, absolutely not. Green technology. So Nadine is also one of my former Saudi Arabian team members. It's nice to see you here. It's my alarm here, right? So she says, will metaverse be against green technology? Absolutely not. That's why I call this energy consumption, power consumption. How can we address this? Actually, it will support the green technology, right? You can do all these environments like, metaverse world, right? And then you can also address these green environments. So it will help actually. So in fact, really metaverse, the one problem is the older generations, like my generation, and also maybe, I don't know, depending again how people are technically savvy, right? Like this is more for younger generation because they were born with these gadgets. They're unbelievable, right? So the metaverse is more for the younger generations, I think, meaning they will help to advance the technology more. We can help them as, old guys and, giving them directions, but these inventions will come from these people, younger generations, because they are in that world, you know, really. So like games and all these virtual worlds, and like their mind works like that, you know. So I expect more. So I think the high school kids should be reached out, and also younger undergraduate students, and hopefully they can create some new inventions. So you had a question, or you want to answer, or what?
Yes, I think you answered all the questions. I don't know if there is any other question from the attendees. Okay, they thank you essentially. Yeah, it has been a really very, very interesting talk. Yeah, I think definitely it's a field that we have to explore much more, because it's an emerging market and definitely an emerging technology. So something to deal with, also to make it compatible robotics with metaverse, definitely.
Yeah, I hope some of the people that they listened, they will be interested, and they will start research. You know, that's the objective, right? To get more and more people into this field. You know, that's the thing that a lot of researchers open their eyes late. You know, like this, you know, I went through a lot in 40 plus years career. Like suddenly people say, oh, terrorism, oh, it's important, let me start to write some papers, or reconfigure intelligent surfaces, or, you know, like massive MIME, all of these in the past. So, you know, instead of sleeping and doing old stuff, just open up and follow, you know, what's the new, especially nowadays, the communication is so easy, that follow these webinars and follow these new directions. Don't be afraid of that, right? So here's a thing that I tell you before you leave. I used to tell this, and maybe it's time after some years to talk about this joke, which explains our research world. So, so there are researchers, friends of mine. I have respect for all of them, by the way. So they are in a field very narrow, 40 years long. They do these narrow things, you know, queuing theory analysis, and, you know, is there and there. And then there are people that they are always wandering around, you know, finding things. But then there are also some people that's really bad, actually. You know, I don't agree. I don't support that. So they go, oh, optical is interesting, so let me write one paper here. Oh, surfaces are important, let me write a paper here. Oh, you know, this is important, let me write one paper. That's awful, you know, jumping around and writing papers. So focus on something and, you know, work on that. So the joke is this called comfort zone. You know, about my colleagues, they do this thing about, you know, 40 years long, same thing. It's called comfort zone problem. So the joke is, you know, in the past, or Italians, let me call it Italian, right? So in the beginning of the century, this Italian comes to New York to visit his son. He doesn't speak any single word English, right? So he wants to be independent, you know, typical, especially Southern Italians are very independent. So he says, son, I don't want to have you always with me. So I want to go to cafe and I want to order some, you know, myself. Okay. So he says, okay, so it's teach me how to say cafe and also, yeah, cafe. And then he says, here's, and then bread, I'm sorry, bread, coffee and bread. So the son teaches and he remembers coffee, bread. So he goes to the cafe and then he's very proud. And then another Italian type guy comes. Of course, he, you know, understands, you know, this guy, like he's foreigner. And then our guy says, cafe and bread. So he immediately brings the cafe and bread and he's so happy, you know, proud. So next day he comes, coffee, bread. After 1 month, says, damn it, you know, I want to order something else. So now he asks his son, can you teach me, please, how do we say the croissant and tea? So croissant tea, he memorizes, and he goes, And that day, an American girl is working there. She has no idea about these things, right? So now listen. He says, tea and croissant. And then immediately she says, how do you want to have your tea? Green tea, black tea, mint tea, this and that. How do you want to have your croissant with chocolate, plain this? He says, he's scared, says, coffee, bread, coffee, bread. So this is the comfort zone. So the point is, so now these guys that they go a little bit out, they got rejections. Oh, I want to go back to my coffee and bread, you know? So don't be scared. Just go out, you know, get rejections and people pound on you.
Yeah, it's an invitation to go out of our comfort zone. This is an invitation to go out of our comfort zone, definitely.
Yeah, that's the point, right? Okay.
Great.
I love that joke, by the way. It really teaches a lot, you know.
Yeah.
Invitation to have coffee and bread.
Exactly.
Coffee
Yeah.
and bread.
Yeah.
No, actually, it's happened to me, by the way. You know, when we moved here, 1985, you know, it's unbelievable. You go to a restaurant, so you say salad. What type of dressing do you want to have? Like blue cheese, Thousand Islands, oil and vinegar, this and that. I was like scared. I said, what the hell is this now? And then really, so, and then I said bread. What type of bread? White bread, wheat bread, the dark bread, this and that. Like, I really got upset. I remember the poor girl was like, you know, she was doing her job, but we were like overwhelmed because we did not know that. You know, in Europe, we say bread and bread comes. Same thing with the steak. What type of steak? This and that, medium, well done, this. And so, so it's happened to me in real life too. Anyhow, thank you for listening.
Thank you so much. Yes, I think the link will be over.
If you need the slides, you can ask me.
Yeah,
And here is another joke. I love joking, right? Life is already difficult. So I charge €1,000 per slide. So I was in China in 2006. I gave a keynote speech. It was about censorship, like it was 20 years ago. So now suddenly one guy gets up in China, Beijing, says, can we have the slides? And I said, sure, but each slide will cost €1,000. And then he was like, they took it seriously. There were 99 slides. And then chairman says, Professor, the session chair, can you do, you know, a better price for us?
Okay.
I'm not kidding. I mean, I should really, when you read my memoirs, so many jokes are there. So each slide will cost €1,000, okay?
Yeah. So thank you again. I think many people will be happy to have the slides here, definitely. So if you can share, then I will share with the others.
In fact, I can send a longer version, right, with all the other ones too.
Oh, wonderful, wonderful. Thank you so much.
Thank you. See you.
See you soon. Thank you.
Ciao, ciao.